Well, I'm finished. No? Go ahead. Great. So, welcome all tonight. It's the last session of our beginner intro course into big data. So happy to see that so many of you showed up during the holiday season. So I'm going to try to make it worth it that you came tonight. And if my part wasn't worth it, there's still pizza afterwards. So you get rewarded for coming here anyway. So how to start your big data project is really a way, and also the learnings we had of doing several projects ourselves and the typical pitfalls we would love you to avoid. And again, this is also an introduction to, we're going to organize this hackathon at the end of the year where you're all invited. And so this is also the preparation of like, what should you think about when you come with the big data project. And so there's 5 main topics we'll be covering. Why most big data projects fail. Maybe I'll ask some questions about this later, but then the methodology and the life cycle of a big data project, the do's and don'ts, the things that we learned and many others have gone through. How do you build your own big data stack from a technology perspective, like which tools should you use, but then one of the main lessons is make sure you first know what you're going to do and then pick the tooling. Don't do the other way around. We're a hammer with a tech stack, and now we're just looking for a nail, and everything looks like a nail. So we're going to address problems that we shouldn't be addressing, and then a step-by-step example, which is based on the real estate prices in Berlin, and a big data model to see what is determining the prices of rent in Berlin. So we're going to kick off. So big data, big failure. These projects typically spend and cost a lot of money, a lot of time, and the outcome of the first few projects in many large corporations is way below the high expectations they had of them. So this is something that we've seen and heard. It's estimated that 80% of big data projects fail, and they fail for 4 main reasons. First one, unclear business goals. Oh, we now have a data scientist. We hire 2 of them even. Oh, and here's our historic data. Go play with it. Find value and come back. Yeah. No clear, like, why are we doing this in the first place? No, go ahead. And then you can work it for 6 months and come back to that. You laugh with it, but many big data projects started that way. Organizations that do not really know how to question themselves, why do we know? Everybody is doing it. How come we don't have a big data department yet? We have so much data, we should be using it. Yeah, so that's one of the major reasons, unclear business goals. Then afterwards, when they did find business goals, and they build a fantastic proof of concept, it turns out that it's bloody hard to scale that proof of concept because it wasn't thought of in the first place. Like, oh, look, here's some low-hanging fruit. It works on my machine. Okay, now move it into production. Oh, wow, now it's real time. Doesn't scale. Then there were 2 data scientists, but there's still lack of talent because they can't know it all. And there's new stacks around the corner that they haven't used yet and they should be using. And so it's really hard to attract and maintain the talent in the data science community because there's a high demand for the experienced people, and you have to learn it on the job to do it. And then lack of security, and I would definitely add privacy by design. Many companies just start with this project and they don't really think like, oh wow, but now we give access to really sensitive data to people who maybe should not be able to get to this data, or why are we doing this in the first place? Again here, is it ethical what we're going to be doing with this data? Can we audit afterwards who has accessed it for what purpose, or what was done with this data by third parties? And we've seen many examples in previous courses of where big data projects went sour because they thought everything was brilliantly anonymized, and then yet not really that well done, so it could be reverse engineered or brought back to a data subject. Let's move to the first one. Unclear business goals. Always start like, why are we doing this project? Not like, okay, but I'm ready. I did this course and I have this tool and I really mastered it in 3 evenings. I want to use this. No, first, why are you doing the project? This, of course, applies to all projects. I see some of you laughing. Like, do you have corporate projects where the why is unclear? Yes? How many people worked? What's the worst case you know about? How many people worked for how many months on a project without a clear business goal?
Me, at least a couple.
A couple. For you? Okay. It sounds familiar. You have more examples? You have one too, or? No? So anyway.
Sometimes it's important to have an exploration phase.
Yes, that's very important. Exploration phase is perfectly okay and normal. I would really.
To a certain amount of time, and then.
Absolutely. So that's part of the why we're doing this. Yeah, it's an exploration phase. Very good. That can be the scope of your project, and you're going to get 1 month to look at this. But that's probably not the big data project that we're talking about here. Yeah? It's the exploration of what will be useful. So the exploration phase is actually part of the why. Like any child, why? They keep asking. For those of you with children, when they're small, they ask why? And then at some point, we as humans forget this tendency. We just do, either because we learned or because we're afraid to look stupid because we don't ask why again. And so many big data projects fail because nobody wanted to be the child that said, well, why are we doing this in the first place? And haven't we done that before just with the relational database or with Tableau on existing tool sets on existing tech stacks? Yeah? So that's one reason. The business needs, like, are you going to find cost savings? Are you going to find useful insights to make more money, new customers, stuff like that? Yeah? And the data that is being valued has to be a strategic asset to your company, but often it's not treated that way. Yeah? It's discarded. It's on, oh yeah, we had that on a disk somewhere, but I think last year we threw that, we gave it to some data destruction company because we thought it were never useful. Where the whole history is gone now, because nobody thought that the signed order forms would have value in the future because it was all in the order system anyway. But it turns out that not everybody and every element of the order form was in the ordering system. Yeah? And so you can't find all the details back of who signed whom, with which person, which salesperson, which back office person managed it, and those data all get lost. Yeah? Often they're not tracked. And then companies focus on collecting data, but they're not able to answer the questions from the beginning. Yeah? So a lot of companies are collecting data without knowing what they will ever do with it. Yeah? And that's, I would say, a project set a portfolio, because either you say like, yeah, we don't know, we can track it, it's exhaust data, we don't do anything, but you know, one day it might be useful, but this completely contradicts the privacy by design, because you typically only collect data elements, especially if it's privacy information involved, when you know for which purpose you're going to reuse it. Yeah? And so this is another part of your business goes like, okay, why are we tracking this in the first place? Can we imagine ways to reuse this? Yeah? And then stop thinking about experiments and get back to identifying classic business problems. Yeah? People want to find the next big thing through the big data outcome that nobody could have seen, whereas there's probably 15 projects that have real business urgency and real business value, where big data could really help to speed up the solutions, and they're discarded because they're not part of this innovation track where big data is put into. So, unclear business goals. Point 1, the data lake fallacy. All water, little substance. So we have a data lake. So now everything will work, right? We've put it together, we glued it together, we identify it where it is. Well, inability to scale. To achieve the scalability, You need to build them in a way that that you understand upfront how it will scale. Are you building a system that will be queried a lot? Will it be query intensive? Or will it be creating and adding a lot of data elements? It's a completely different architecture, as you saw in some of the previous courses. Like, I know that Dan gave a few examples of those. Like, do not just take the technology and it's put big data washing on it and then it will do anything. No, it's very different on how you will use the system, whether you're querying, whether you're adding, whether it's real-time, whether it's process data, whether it's an archived data sets, whether it's live data sets, all that matters, how it will scale. This is the part where people use, I'm going to the cloud, I'm using Azure, AWS, or any other cloud platform, and it's for the proof of concept, that was fine. They got a credit card out and it worked. And now we're going to plug in the real-time fire hose data sets. Boom. 10,000 euro the first month, 50,000 the second month, 100,000, because they forgot to build it for that scale and it could evolve cheaply, because everything goes in there. It worked for the proof of concept, right? And so this is a huge one to consider, the ability to scale, to build it into your platform and think up front. So for the exploration phase, it's perfectly fine to try approaches and do stuff, but that's a very different approach from getting your exploration phase into production. You should learn something, and that should be the input of the system you build. And you start with a small data set. It sounds a bit weird that we're doing big data, and then we said, okay, start small. Because the learnings from that will help you to get the value out of the small data set and then apply that to the bigger one. And then big data workloads, they really tend to be bursty. Everything blows up. Because it's, as soon as you are moving into duplicate data, normalization, you want to keep all the history. For example, the more you track and the more users get access to the data, if you want to have a data governance model where you track which API consumed which underlying data for which transaction, you're creating huge logs of that. And so your big data system is now generating huge amounts of data in itself, which might be training data sets for another product. Yeah? But so they're very bursty, these projects. So allocate enough capacity, and again, that's where the price goes up. Yeah? So from the cheap POC to the production can be like a multitude factor together. Then to infinity and beyond. So now we're driving in this case, a car. There are big data project. Everything is going fine. Let's scale up, right? We push down the pedal, we get some more power, we go up. We know there's no road, but everything is going to be fine because look, we're going up. Somewhere down that road, gravity kicks in. Yeah? No matter how hard you drive, you will get down. It's like the Roadrunner cartoon, for those of you know, it's the beep beep, and then they always fall down the rocks. That's probably only appealing to the older people in the room. These cartoons were exactly that, the good and the bad following each other and then flying over. Why? Because it's hard to test those large systems. So it looks like we're in control, but because we're processing so much data and we have so much underlying data, the test scenarios are really hard. Processing time goes up. You need to have all those instances. If you raise the data volume to process, you'll be kicking up more processing time instances. And then technology can and will fill. At some point, there's a new bottleneck that you didn't hit before, and it will clog everything up and everything stops. So now you're losing on transactional production data that was supposed to be added to the message queue or to the production data set because something was overcharged. You didn't have enough processing time and it clogged up the whole machine. That typically happens at some point in every data project. Like, wow, this used to be fast. Now we're to 2-minute response times. How come? Oh, yesterday 2 minutes, today 3 minutes, something is going wrong. It's the signs that technology is about to fail and that your system wasn't built to scale, of course. Yeah? So building a really scalable system means that you're going to do quality assurance, you're going to start measuring from the start all those elements so that you can quickly see, okay, that's the first bottleneck, second bottleneck. You had a question? No? Thinking. Good. Lack of talent. I guess that's why many of you are here. And I think it's a very good sign that you chose to follow this course, especially if you can also come to the hackathon or follow the advanced one. But so, if you are an experienced data scientist, I can guarantee you will not be without job opportunities in the next decade. Yeah, There will be a lot of them needed by companies, governments, people that can ethically and with a business insight get insights and decisions out of large data sets. So I would say that's a very good trade to be in. As a knowledge worker, it's extremely difficult to hire good data scientists. And I would almost jump to one of the conclusions, like, don't expect that you're going to hire the data scientists that can do it all. You will be training people and they will learn on the job. So there's not, so even the ones that have done previous project, there's also always new elements. The hard part is you do not just need geeks and developers, you need people with domain knowledge. Yeah. They need, and people skills. They need to understand the data that they're trying to crunch and that they're trying to get insights out. Because you can find many insights and you go to the domain knowledge experts and you cross-check and you say like, okay, I found this unique insight. Let's take a very stupid example. A data scientist is given a data set about cancer types and he looks at correlation and sees, wow, women get ovary cancer. And he goes to the doctor and says, I found huge correlation. There's an insanely high amount of women getting ovary cancer. And the doctor will say, where do you live? Men don't have ovaries. They can't get that type of cancer, yeah? Ah, okay, but okay, I just spent 2 weeks finding that unique correlation in this, in all the reports that were written about the doctors. Because every doctor knows, and this is of course a laughable example, but you can see the extent of it. It's laughable because we know this, but that's what domain knowledge is about. Yeah? So to a doctor, that's domain knowledge. To a data scientist who didn't follow a biology course, this is like, couldn't you have told me before? I would have looked for other correlation types. Yeah? So, many big data vendors, so because there's little knowledge and experience, most big data vendors, they have educational resources and they provide automation of platforms. So they build in all sorts of training programs and tooling to take away the needs and the knowledge to address those first problems. We mentioned a few before. I think DataIQ is one of them, like an out-of-the-box platform. It tries in parallel X number of approaches. It shows you visualizations, we'll come to that later, and you get something out of it. Yeah? So that's what the vendors are selling you, an out-of-the-box solution, but then the real work starts afterwards. Which model was appropriate for my problem? So again, to the why, which problem are we trying to solve, and how can I replicate and install this to be scalable? The tools, they keep evolving. So when we started out doing this, we were in early days. Now it's like, I would say on a weekly basis, you have not just new tools, but new releases of tools that can do new things that were unimaginable 2 or 3 years ago. And then 57% of organizations, they cite a skills gap, and this is then typically one of the very popular tools is Hadoop, the Hadoop stack. They don't find the people. And so that's one of the early big data stacks, the Hadoop stack. It's hard to find people that have done these projects at scale. Yeah? So again, lack of talent. Another reason, the big data unicorns. You add this Venn diagram to that one and you get a big data unicorn. You all know what unicorns stand for? Yeah, so that's the valuation of a startup at $1 billion, that then they become a unicorn. And so it's a combination of having the technical capabilities of development, of quality assurance, what I said, that you measure how are we doing in each step of our technology stack, of running the IT operations, all the virtual machines and all the nodes and all the compute power and all the storage, and that's then called DevOps. Yeah? So DevOps, the DevOps and engineering part, where you are both marrying the development part, and the ops is one role. The developer pushes his or her code into production, and a DevOps role will be able to understand the effects of both sides of that. And then you have computer science using big data, subject matter expertise, and statistics, yeah? Math and statistics. And so if you have those skills in a company, the technology capability and the data science capability, you are on a good trajectory to become a big data unicorn. Now, lack of security was another reason that we cited before, and security and privacy. So, user authentication for every team member accessing the data. let's take the example. Some of you work in IT. When you get the data set, are you able to install it on your machine? Yes, you are. Is anybody afterwards able to see how you wrangle those data? No, they aren't. And so from a data governance perspective, that's not supposed to happen. Yet today the reality is that many data scientists just get the raw data at their disposal. They can play around with it, as you said, in the phase where they're looking for correlations. And even afterwards, they have very privileged access to cross many data sets that are really protected and sensitive. And so there's more and more vendors selling solutions in between. One of them is a famous Belgian one, which is a unicorn, by the way. It's Colibra. And these are like data governance models, which help companies. So it's a layer in between to see which element was accessed by which person, which team, for what purpose. And you have audit trails, and that's what I say. It bursts everything up. But those platforms are being used by large organizations, so typically banks, multinationals, because they are afraid that team members will access data in inappropriate ways. Yeah? And so you can restrict access based on a user's needs. The data scientists don't like that because they like to get access to everything because that makes work a lot easier and faster. Typically, recording the data access histories for compliance reasons in a bank, who looked at which data element, for in the police, which police officers looked at which criminal file. Was this for their neighbor, so that's not supposed to happen, or was it as part of their job as an investigation? Hospitals, same thing. So all this logging for compliance reasons, like who can see what for which purpose. Yeah? Really, really hard to get properly installed. And then use encryption on data in transit and when you compose it. So try to encrypt at all the middle, but there's no use of you putting, and there's like, I think 1 leak a day of a S3 bucket, which is storage as Amazon, of people who leave the keys in the open in a file on a let's say that they put them on a Google Drive, which is then shared, and then somebody finds a document, and there is the S3 key, so you can access everything in a data storage because it wasn't encrypted properly, and the keys were shared publicly. Yeah, often a combination of both. Yeah, but so it doesn't have to be encrypted. If you can just have access, but if the encryption keys are in a public file, it's just as good as not encrypting it. Yeah, so many data leaks are at cause there of people who they have a large customer, they share something that would be the equivalent of FTP in the old days. You give a login and a password. Well, this now happens in the cloud, and by lack of skills, people leave those resources open, and there's all sorts of scanners on the internet that will just try all potential addresses in a big data stack to find that vulnerability that opens access to a data source that was not properly protected. Yeah, so another reason why security sometimes kills big data projects. Companies are afraid of that, and so they hold back of doing too much of that. So one of the most important ones to me, with great data comes great responsibility. Yeah? So when you are in the privileged position that you can look at large and can wrangle large amounts of data, this gives you, I won't say superpowers, but it does put you in a very responsible position. And I think this is something that's not being discussed enough in the big data cycles, because it's very much about technology and business purpose, and much too little about what can we do, for what purpose, and is this ethical? Yeah? And in many of the machine learning and the AI projects that we've cited in the past, there's bias. And so the whole issue of bias, either because of historical reasons or anything else, is a huge issue in big data projects, because you're inserting past behavior in future decisions if you're going to do predictive analytics or decisions based on those historic data sets. And so there is really great responsibility for the ones building them. If we want the advantages of big data to be used, it needs to be trusted. It needs to be accountable, and it needs to be built by people that can answer those questions when they're challenged. Like, hey, you've built this horrible big data project. It can now do things that we never wanted it to do. Should we do it? And so even in the big technology companies, not to name them, Google, Amazon, the internal engineers are having big discussions about facial recognition. Should those technology companies sell facial recognition technology to the army? Or should you sell it to the Chinese government, which then can use it in Hong Kong to recognize the faces of the protesters, to link that afterwards. So when you see them, they're wearing masks, it's not because of the bad air, it's because they're very conscious that they're being filmed, and that through the facial recognition software, the Chinese could identify all those bad citizens, so that in a future stage where there is extradition of Hong Kong nationals to China or residents to China, they can use that, yeah? And they can punish you for it, for being there. And so this is technology. The technology is available. It's out of the box. It's available for each of you. You can install OpenCV. It's open source, and you can do at a very good level, very good facial recognition. The question is, who are the people implementing that on massive scales, and for which purpose? And so I do encourage each of you to think carefully when you build systems. Is this something that I support with your own values and your own moral compass, as something that I believe is in the interest of my company, that I can justify within the law and within my own principles? Yeah. So, anybody has questions about that part? Other examples of things you heard recently that went horribly wrong from an ethical point of view? Have you encountered it in the past, that they ask you to build something that you say, wow, I don't feel comfortable in doing this? No? Nobody wants to talk about those projects? Good. So, understand, this is the governance part. And I said it's really important, but really complex. So understand the industry point of view on big data. In certain industries, it's forbidden, even by law, to do certain things with it. For example, French insurers are not allowed to use social media data to make a risk profile on the people they insure. They're not allowed to use the fact that somebody says, I just went to the doctor and had bad news, to say, oh, now I'm going to refuse your health insurance, or I'm going to give you a higher premium. They're not allowed to do that by law. Same thing, France has made a law, I think it's still a proposition, on legal data, that you cannot make predictive analytics based on which judge has made which judgments. So they have a proposition to outlaw that. Whereas from a data science perspective, that's super interesting. Yeah? And so sometimes those laws, I don't agree with that one, for example. I think you should be very cautious what you do with the link, but I think it should be open data to know judges are accountable for their decisions, and through their function, it's a public function, this to me is not an issue that you could know and mine which judge has what decision. It becomes very problematic if you start selling tools saying, if you come in front of that judge, you will win or lose, or you in that position will win or lose. That is something I'm completely against. Yeah? But I think we should be allowed to open and to give scorings based on, in that case, with those circumstances, that judge give that sort of penalty or that sort of decision. Yeah? Very close to each other, but not the same. Yeah? So from an open data perspective and open case law perspective, I'm very much adhere to that standard, because I believe it will raise the quality of the judgments. Because if judges know that they're being looked at, if they're consistent for the same thing, do they give the same penalty with the same law? Or very rare to see business measures on how much will it cost and how much will it bring. Accountable. How many customers? Will customer satisfaction go up because we now... the lakes 1 and 2. The life cycle, again, the data science life cycle, we start with the business understanding. So there's a little bit of repetition here. As they say, that's a good master if you want to get into any skill or knowledge. Business understanding first. Know what you are looking at before you start using expensive big data tools and process power and something that you can't understand. Yeah. Data mining itself. You might need to gather it internally. You might need to scrape it. We've talked about that before. There's lots of public information out there. Some of them is really open. Others have gray zones. So look at the license. Can you use this information for that purpose? The cleansing, step 3. That's where all the blood and the tears are flowing, because that's where you spend as a data scientist most of your time. So that's the part of disillusionment is in step 3. Like, oh, I need to deliver in 2 weeks and I'm still cleaning the data to even be able to look at them. After you clean them, you can start doing your data exploration. And after there's a little step back, because during the data exploration you will find out that you didn't clean them exactly as you wanted them to be cleaned, and so you might go back to the data cleaning to get better results. Feature engineering. So the import features make more meaningful ones using the raw data than the ones that you have. So that's another important step. Predictive modeling. Now that's already when you've done the 5 before. It's using the historical data and using the machine learning models to evaluate the performance and then use them to make predictions. So you're building models now to make predictions. Typically, weather predictions are very, very complex models behind them. Yeah? There's, some of them are publicly studied, other them are proprietary, but there is a lot of predictive modeling to know what's the temperature in a week, because you need to take a lot of sensor data from satellites to Earth observations to clouds and so on. Then you visualize it. I think the weather forecast is a great example. It's a very simple visualization of having a cloud or a sunshine with a temperature to it, a wind direction, the data visualization. There's many models around, but basically when the elements in there, they're all the same. Yet nowadays, you have these mobile interfaces that are like real time. You can do time tracking in there, go back in time. In the data, have you seen those? You see really the model all over and it's changing in real time with the observations with all the sensor data, and then you can scroll in time to see how the high pressure field is expected to move and what the consequences are on wind direction, pressure zones and temperatures in those underlying regions. So it's the next step of data visualization. Wasn't possible before. People were just getting a feed that was printed in the newspaper, was shown on the news. Then we had websites. Now we have apps that really go very, very deep, and they have a free version, freemium model. The one with delay, for example, the buienradar, you know that one? It's when it's going to rain. This was an entrepreneur that basically bought the satellite feed of the rain data and then built a revenue model on top of it. It was one of the most popular websites in the Netherlands, then came to Belgium, selling ads on top of the weather. So, oh, you want to have a barbecue, you want to have a party in your garden, you will need to get out of your front door and you want to know, is this going to ruin my exquisite hairdo? As you can see, I don't have that problem, but it's somebody seeing the opportunity of a data feed, in this case satellite data, on rain falling down out of clouds, and finding a business model to do something with, and building websites, apps, and predictions on, for the next hour, this, they score it, they basically get, there's an 80% probability that it will not rain. Okay, now I can go out. Yeah, I'll keep my haircut. Business understanding. So, again, we've gone through it a few times already, but fuse analytics into your decision making to improve the core operation. So, make sure that you find those new opportunities, but to find the new opportunities, you really need to understand, what do we do today? Where does my company has already announced or established that we are going tomorrow? And then maybe which new insights can I bring to talk to my organization? I think we should be going there, because you said we should go in direction A, but we should go in direction B, because I can prove you with my model that there's much more potential for us in that market. So competitive advantage analytics to identify your capability, strengths, and weaknesses. So it's a SWOT. You map it, you look at your competitors, you look at where the market is going, and you can help that. Determine the deliverables. Again, and this is the business understanding. Make it measurable. That's a part of the MVP where you measure. Same thing here. Determine what you will deliver. What's the output of your big data project? Know it up front, quantify it. So you identify the business objectives. So that allows you at the end to answer, was the project successful or not? What did we learn? Even if it was not successful, you will always have learned something. But if you did not qualify it up front, what you were going to succeed or expected to succeed, it's very hard to say, okay, we made it or not. Oh, we had a fun time. We spent months on this cleaning of data and finding this correlation. But the result was useless. Okay, how come? How can we avoid this in the future? So, what drives the most value? What hasn't been mined yet? Are you the first to do it? Do you have a better way to do it? Are there new tools available that allow you to gain insight that others couldn't gain before? And what hasn't been explored yet? And the data mining itself, several ways, and they're interconnected. You connect to a relational database. That's still a large part of what companies have today, are relational databases, and linked to those, the whole fact, I would say, of structuring the data. But it can even be private data. Login, if you use it for the purpose that the people have given it to you, the data subjects, and understand what your company has been collecting. So connect to a database. Then use APIs, application programming interfaces. That's how servers talk to each other. There's an insane amount of very useful and cheap APIs out there to immediately enrich what your company has in their own databases. So you don't need to do all the structuring because it comes to the API. You call an API endpoint with a certain value, you will get a response back with a data set that is well documented and where you know, now I can glue this element to that one in my customer database. I can enrich it, and from that you will find a unique insight because it's in the combination of those proprietary data, the open public data, the APIs you buy, and don't forget the open data. There's more and more of them that you can just get from a government website for free. You don't have to justify why you're reusing it because it's open data. And once you're there, you might even want to create your own APIs or use more of them internally and expose your data in that way too. So just know that you can get the API from Twitter or from Facebook. Those are feeds. But as said again, it's going to be expensive if you want to have what was once called the fire hose of Twitter. That means that you get all the tweets sent to you. I can tell you there's a lot of them. So you might want to have a filter on a keyword or a region or a language, and then you get less API responses through those ones. Same thing for Facebook. A lot of things went wrong because scammers managed to fraud the APIs that were not supposed to use in that way. I do a quiz, I ask you to refer to a friend or describe a friend, the friend logs in, and through the API I now have the network of friends of your friends. That friend didn't know it was going to be used for that, and you didn't know you were, by inviting that friend to a quiz to check how he or she is comparing to your results, that all that was going to be a data trail to make a campaign really look like, but you were voting Democrats, so probably your friend was voting Democrats. Now I have a whole network of people who I should influence with messages against or in favor of a certain political battlefield question domain. Data cleaning. Again, the whole thing is start digging and try to link it to try to answer that goal. And we keep repeating it, but you need to set the goal and try to answer that. And so when you clean, you already have that goal in mind. Like, I want to get those elements at the highest possible quality out there because, for example, I want to make a graph model afterwards. So I need to have unique entities so that I can link them together in a meaningful way. So I can put on an address sign, on a person sign, on a business, a factory logo, so that when I go around my graph model, I can see the type of links between the companies and the persons and the addresses, to name just three main relations that are often used in business graph models. Analyze and ask questions to the business or IT to understand what do those variables mean. Sometimes something has a label for historical reasons and it was then used or misused for other reasons, especially if it's old systems that are coming from the mainframe era that evolved. I see a few of you thinking about those in practice. There's a lot of labels that do no longer correspond to the data that they refer to. Yeah? So ask like, why did we name that? From my exploration phase, I can see that this is no longer the value that is being described in the header, and yet we are calling it from a production system to track our customers' progress. Now, fix inconsistencies and handle the missing values. That's a very, very, very hard one. Because you might find errors in the data sets, but you might not have the authority to correct them. And so it's very hard to say, am I going to label it as missing? Or can I deduct that I have another field where I have the same element, and am I going to insert that one? Or if I have that element in two different spots in my data lake, which one is the authoritative source with the highest probability to have the good value? And what are you going to do with that? And then you need to go back to those business people and ask, like, what do you want me to do? Should I fix the inconsistencies or leave the inconsistencies? If you know that an address has been renamed, should you correct it? Should you correct it in the production data set? Should you complement it in the historic data set? So that if you do an analytics on where did we deliver, it still results to an XY coordinate. So should you do address scoring if we talk about addresses? Should you put the shortest XY coordinate with an address? Because that's something that's fixed. However they rename the street in the future, you will always be able to pinpoint to that location. And so when you make models about distance and where did we sell and was the density of a certain area where you're selling, or and taking the business example here, or where there's an outbreak of some disease, that you have something that's time proof. Is that example clear? I gave the example earlier about the addresses. I don't know, but not all of you were in that course. But so imagine that you have an old address in there, and you have an outbreak of a disease that is, I would say, something that could, a virus. And this happens every few years in an area where the street mapping is maybe not always consistent. If you have XY coordinates and population densities, then you can work that out. If you used in your old model certain street names or city part names, and you didn't have the population correctly to the same region, your model from the past will not work on the future. And so if there's a vaccine against that virus, you might not be able to send the right amount or to the right area just because you didn't map the addresses or the regions of your research or the outbreaks correctly. And that's just one stupid example. In the developing world, address data is a much bigger challenge even than we have in the Western world, where everything has been labeled by governments. So, data cleans equality. You have consistent data, so you can again visualize that, inconsistent data and missing data. And then there's platforms like Trifacta is one of those. Like in this cleaning, that's where you spend your time. You're going to score and validate. Aha, I have a first name and a last name, and I have another field, and the last name is the same, and the address is the same, but the first name, like the number of letters I get where I am Tom instead of Toon, is very high because it's a more popular first name. So people on the phone or in some CRM systems, they put Tom or Ton. And so which one is my correct name? Then you have to go and think internally. I now have 3 persons living at this address. I have a Toon Vanagt, a Tom Vanagt, and a Toon Vanagt. But I have an email address that works, and the mails don't bounce. I've got an order, and in the email address I have first name dot last name. I can be pretty sure that that's probably the right way to write the name. But then again, maybe I would have done T Vanagt. It wouldn't have helped you in any way. Or I would have been one of those companies where they abbreviate. I would be to.va at something. Yeah, it doesn't help you either. So you need to make rules about in which cases can I use which date. And it's just a stupid example, but it's a real one. To see, like, at some point people filled in discounts in an airport, in a shop. They send in the form, it was processed manually, and there was a data entry error. It ended up in your system of prospects. Maybe I'm a very good prospect to you. Oh yeah, because you sent me an email newsletter and it didn't bounce, and I clicked every month on your newsletter to see the promotion. Now I'm a well-classified prospect. You want to send me a paper brochure. I wouldn't do that in my case, it would go straight to the bin, but imagine that's your marketing strategy. We're going to send something, a sample, because after sending a sample, that person will come and buy. Okay, I'm going to send this. How do I address that person? If my first name is written the wrong way, I will attach less value to your respect for me as a future customer, because like, if they can't even figure out my first name, it's probably not a good, trustworthy party. So those very easy and well-spread data elements are extremely hard to manage on a corporate level across all the customer databases and other places. Look at the number of email addresses. Who of you has more than 2 email addresses? Just a show of hands. 1, 2, 3, 4, 5. So we have more than half of the room has more than 3 email addresses. Yeah. Why do you need that? Do you have anything to hide? No, it's perfectly okay. Just know that next time you travel to the US, you will be obliged to give all your active email addresses. All the I think you even have to give all the ones you used in the last X years. If you don't give them, Homeland Security has a reason to say, you must be hiding something from us. Your terrorist messages, they didn't go into your Gmail, right? You used some Proton Mail or something, and you haven't disclosed it to us, so now we have ground to refuse access to our territory. Yeah? And so more and more questions about, it's just an email address, it's just an alias, you don't really own it, it's owned by the domain owner who can do with it whatever they want afterwards, and the mailbox in which it ended up is where the data is being stored. But it is something that's being used, it's an identifier that's in almost every modern data system. So, data exploration, that's the fun part. And as I said, there's out-of-the-box solutions. Here's one of AGILE SynMe. But so, you typically try to find you do your initial data analysis, find what's similar. So, you use visual exploration because for us as humans, it's the easiest way to see. On the next slide, I'll show you some examples of all sorts of data visualizations that you get out of those data exploration tools. But it's a combination of automated and manual activities. Some of it is plain simple and gets out, and some of it you have to think and know what you're doing. So there's many different ways of doing that. They're typically, the abbreviation is EDA, so Exploratory Data Analysis, and a very typical one in 2 dimensions are the scatter plots. So you have 2 axes, and you will see how correlated they are, that you can see the trends on there, and that's a very good. You can do bubbles, and by the color and the size of the bubble, things are more. And so we as humans will want to know, okay, it's quite linear here, but so I want to see this blue outlier here. What is that? Why is it there? Does it make sense? Could we influence it? And so on. Find correlation. You can find the density typically in the bell curves that you that you plot. That's when you have many data points. When you have few data points, you might just have a histogram of seeing data points. So that's the visualizations, but they come after the descriptive statistics phase. So we have the central tendency of a distribution. We measure the variation, and then you have the skewness and what is called kurtosis. So that's the peakness relative to a Gaussian shape. And so that's the Gaussian shape here. When it's very short, very high, we will say that the kurtosis is high too. So that's a very peak graph in there. And so those 2 things together, the statistical part, the descriptive statistical part, and then the visualizations that help you to see it, that's the part of the exploratory data analysis phase. Yeah. Then we have the feature engineering. We have all the raw data. We do the feature extraction. We have features, and we might feed that into the algorithm, machine learning, the statistics. It can be trained, it can be doing predictive analytics, whatever. But so that's a very, I would say, very low-level visualization. How you can select the important features and then construct more meaningful ones using the raw data. So again, you're going to iterate here to see what's useful. Again, predictive modeling. You cluster your algorithms, and you can get models to uncover trends that were not distinguishable in the graphs and the stats. So we create groups of similar events, we cluster them, and we explicitly express What feature is decisive in the results? So that's the whole important part. Find the features that influence your end results. That's what the whole modeling is about. Find how those two. And then the data visualization, we already spoke about a few before. Ooh, the pizzas have arrived. Now I like that visualization too, as you all know. We don't have one of those on here. But so I'm standing in between you and the pizza, so we're going to ramp up the speed now, because as all of you, it's summer, and we're not going to make a long night tonight, I promise. Interest rates and loan amounts. Interesting distributions. Yeah? You can make, if you see this, you can immediately say, okay, how much are the rates on if you take a loan on a small amount, you tend to be paying a lot. If you take for a longer amount or a higher purpose, longer term, you'll probably pay less. There's maps of seeing like where do you have which type of loans. So they map those two together on a scan, the combination of loans and where are those houses. And just as an example, you have the box and whisper plots where you can say, I find this result, but that's the variation. It could be between that and that value with a certain propagation, but so those plots are useful to say, how certain am I about my end results? Because if this is that big, basically you can go back to square one. It doesn't mean anything. The value can be in the whole length of your graph. Yeah? So you typically want to have a clear box and whisker plot that shows we found something meaningful. We know it's not perfect. It still has variation. It's all based on statistics, but we can see that this is higher than that. Yeah, that's something we can tell, and the variation is similar between those two. Monthly income, again, this is not symmetrically determined. This is skewed to the bottom part, and then there's fewer people making very big amounts of money in a monthly income perspective, and so on. So I'll let you look through all the others, but typically those are the things you see in visualizations. I don't need to explain you much here, right? Because you can see, even with being able to read all the details on them, what they do and how they visualize something of importance. So best practices. Start small, low-risk project. If you can find those, you already have rigged your chances for success because it's manageable. Yeah? Make your analytics plan and process. Yeah? Very important one. Ignore the trends of everybody should be using and then put in the buzzword of the day. Oh, they just raised, I don't know, another 500 million and they're now a unicorn. And because everybody does that, we should be using this. So when the CTO comes by, and I hope that he or she will not do that, but the CEO, like, are we using buzzword technology? You feel enticed to say yes. You ask the why question. Why would we be using that? I read about it in the New York Times. Very good. And did you see what they used it for? No, I just saw everybody is using it. Well, that's actually not correct. So know how you can also explain why you're using your tools and not others, because it's an informed decision you made and not based on some buzz that everybody seems to be hunting for the moment. And make sure it's cost efficient. I'm sure that CEO will be very happy to learn that you thought it over and that your tool and the compute resources you needed to run it were 5 times less expensive than the new kid on the block that is compute hungry and use a huge server farm to be able to boot, I would say. Don't obsess over those tools. Really, it's not the most important thing. Many people start with that. No, start with thinking like, what could we do? Understand those computational limits. There are limits to, we haven't reached that phase yet where we can say, I'm just going to take everything I can get and look at all the potential approaches and then the predictive algorithm will roll out of it. We're not there yet. And even in the era of quantum computing, it will take a while before we really enter that into production phases. So the main one is clean your data and make sure they're usable. Don't find those unicorns when hiring. I already said that before. You'll need to train people. You need to learn on the job because it is a learning curve. I'm still learning every day. I can definitely say that all the people on my teams, they're still learning every day. And you learn from each other and you learn from reading online and you learn from listening to talks of how others approach a problem. So, pitfalls. We want to treat this like in a typical engineering project. We know the beginning and we know the end. Yeah? And this is not one of those, and I think most computer engineering problems are not like that anymore either, but it's not a known map. Yeah? It's an unknown, it's an agile journey, and you'll be exploring and learning and iterating. So return on investment is working against you, because you need to invest considerable amounts in knowledge, learning curve, which means time, computer resources, access to data, validation from the legal and compliance department, acquire third-party feeds, access from the IT department on resources that have been in storage that's no longer accessible easily, and so on. And so it's very hard to justify the return on investment, and yet I think you should have one. It should be clear. You can perfectly say, this is going to be a 2 million sinkhole project, but we will learn a lot from it, because maybe it will cancel the 100 million vision strategy that you've explained to me, where we want to go in this industry of building a platform to do X, Y, Z. And I can already prove you that we do not have the resources to be able to fill the platform or sell to the platform or have the resources to matchmake on the platform and so on, because you do this product. Lack of clarity, again, very important one. Make sure that this problem is well defined and justify those investments accordingly, and that showcase internally. There's a very big, the worst thing you can do in a big data project is to say, thank you, I'm going to look at the data that you've given me access to, thank you for the money for the computers, I'll be back in 6 months. And after 6 months you said, we didn't find anything, we need another 6 months. No. Go for bi-weekly, monthly meetings, status reports. We already found this. But that's the ovary cancer not happening in men. Thank you very much, but stop looking for that one. Please go look for something more meaningful. Yeah? That's typically why you want to keep the business side informed about the status of your project, because otherwise you'll be wasting a lot of time. Typical stacks, and I said I can smell the pizzas now, so I'm going to go very quickly through it, but you have input, unstructured data, you have the processing capabilities, you have all sorts of tools. You get the slides afterwards, so you can go and just Google. So there's free open source Stanford libraries for NLP, so that's natural language processing, machine learning algorithms, there's address detection algorithms. So these things just come out of the box. Yeah? You don't have to build the entity recognition capability to do that. You just take the Weka library and it will work. You can do all sorts of data lookups, bank names, airport names. Those are libraries that are just available. You don't need to go and figure that all out yourself. You just can take that for free. And then there's output, pre-configured entities that come out of this processing, relational entities, contract parties, contract dates, company addresses, a typical thing. I keep repeating those. Sentiments for mood, for feedback, for reviews. Like at the end of this course, and before the pizza, I will give you the satisfaction survey. Yeah? It would be great to get your sentiment from that. Yeah? But maybe we could detect that by filming how this is happening, who's doing it very quickly, who's already looking at the pizzas while he or she is doing that, stuff like that. And then we would have a sentiment analyst like, yeah, you said it was fine because you want to be nice to me, because you assume that I'm going to be reading these as you leave the room, which I will not be doing, by the way. It's, only Lucas who will be treating these. But the important thing is that you can get input in many ways, and so sentiment analysis is one that's used a lot in anything that's related in a consumer business to know what they do. So, architecture, components, again, you get the slides. You have your whole data, the orchestration of everything you're doing. Your data sources, you need to store them, and you need to ingest them in real time, float. You can do the batch processing, you can do the stream processing, you'll have the machine learning in between those two, you'll push them to an analytical data store, and then at the end result of that, you have your analytics and your reporting. That's the nice little graph. This is the tip of the iceberg. That's all the part underwater, the hard part you don't see at first. So here's one overview, filling those in with typical stacks. I will not go into that one now. It's typically things that we will do in the next course, the advanced course. We will use all those stacks. Not these. That's just to show you there's too much out there. Yeah? but we'll go for this type of stack. So for data store, MongoDB, very popular one, MySQL. Who's using MySQL in the room? I do expect a few hands to go up. Oracle. Yeah. They are moving those platforms from SQL to unstructured too. So there was this whole movement about no SQL. Well, there's still a few out there, but it's getting less binary as it used to be. You have to transform. Typically, Spark is one. You need to model that. Again, Spark is doing that. You need to visualize all those. D3, it's a library, JavaScript libraries. You can just apply them to a text file. You take some a JSON file with data. You put your D3, on top of that, and you can get out of the box for free fantastic visualizations. And there's many other tools. You know, my two last startups, Data and Lex, are built on what this logo represents, which is Elasticsearch, which is very good when you have unstructured text and you want to do a full text search and all sorts of metrics on top of that and build products on there. Storage, again, are we going to go SQL or no SQL? We saw this in previous courses. So in the SQL world, it's relational, it's very structured. You have columns and rows. In the NoSQL, you typically go for key value stores, extremely performant. You can run them in parallel, you can split them over shards and then consolidate the end result. So you can look through a lot faster than in the classic SQL database model. But there's also downsides to it. So know which one you will pick. The family of the NoSQL databases, here's a few of them that are very popular. I think MongoDB in the document database has gained a lot of traction. If you look at wide database columns, Redis is one that's DynamoDB, React, Aerospike, those are really popular ones. If we go to the graph database, there's Neo4j. If you look at the Panama Papers, you know that leak where a lot of fiscal information from auditors was leaked. Neo4j was used to do the exploration of those links and to quickly see which company that which ghost address is being used by which persons, by which agency, by which intermediate, by which ultimate beneficiary owner, and so on. So that's a graph database. It shows you the links. It's one of those spider webs. You can click on them and do discovery in a visual way between the underlying data elements. But to generate that, it's really a technology set on its own. And then you have key value databases, Accumulo, Hypertable, iBase, Cassandra. Amazon has one out of the box, SimpleDB. So those are your key value databases. Very good for computing huge amounts of data. You just have this key value store. The data ingestion, again, a few examples. These are exactly the things that we'll be talking about. Hadoop, HBase, Hive, Solar, and Elasticsearch are in a similar field, Cassandra, MongoDB. Those are the stacks that we'll be using in the advanced course. So you get familiar with these buzzwords. To most of you, they mean nothing. If you're running in the data science world, you'll be hearing those alongside with R and other technologies. So data ingestion, again, many of the things you've seen before, the same buzzwords coming back. And then those end user tools, and look, we even have Excel on there because it's still used a lot in the business world as an end tool after getting all the results out to allow the business managers to do something with those insights and end results. Yeah. And the free one here is R. That's the logo of R. And R and Python are two programming languages and that are really used a lot in the data science world to compute. So if you are thinking about learning over summer a programming language, I think Python and R by extent would both be good candidates if you want to move ahead. Really at the hardcore nifty, getting your hands dirty on the thing. I'll just leave this slide to what it is because it's certain of them were used, the OpenRefine. Who's been using OpenRefine after the introduction by Mathieu? You got a few. Who's been trying it? Who was here that course? That's maybe good to know. You were here? You learned something from that?
I don't remember.
So it used to be a Google tool that now became, that was open and that allowed you to very quickly add and extract and correct data. So typically you didn't have labels on the tables, headers. you will see names, you add it and it will be added everywhere. Remember those tooling? You found like cities, you found Antwerp and Anvers, you can say it's the same. Yeah, and so from now on you have normalized the city and so on, just different languages. So again, Tableau, very popular one. In this space of visualization, there's been huge acquisitions. You know, to look at that, both Amazon and Google bought went in a shopping spree there. On this URL, there's 24 data science projects. So again, they're in the slides, so you can check them out at home. We'll just pick one, and I'm really going to speed it. So this is about the housing prices. What's driving the rental prices in Berlin? So they were like, okay, how can we combine core to improve the quality of those data sets and move up the ladder by asking users for input? So that were the things. So what did they do? They got the data, they cleaned them, they made an interactive dashboard, and again they had all these nifty parameters. Does it have a balcony, furniture, equipped kitchen? What type of apartment is it? Is it a penthouse? Is it a more classic apartment? Is it a loft? Does it have an elevator? In what condition is it? Is it new? Is it old? Is it refurbished? And so on. And so they normalized for all those apartments, all those elements, and then you can make that sort of graphs of seeing like, okay, if I look at the price of the apartment and per room, this is the monthly rent I'll end up with. And so if I want to have a 6-person bedroom apartment in Berlin, I'll be paying 3,000 euro per month. Yeah? I don't know the time frame when that was taken, because rent prices have gone up in Berlin over the last few years too. And so they did the mean rents, the apartment types, so most of them were normal, how they were distributed on the maps, and so all that information was open and public data. They didn't have to go to government to buy anything there, and you can find all the elements and see the correlation. The number of rooms seems to be a very important decision factor in how much rent you'll pay. Makes perfect sense to us all, right? Recently, did you see the debate about the mobility score in Flanders? No, it has been a huge debate because the Flemish government put a tool online where you could type your address, and it would tell you how sustainable and how, from a mobility perspective, your house is. So if you live close to a school and a shop in the center of town, you get a high score. If you live in a farm on the outskirts of town, you probably have a bad mobility score because you need to take a car to go to the grocery store, to bring your kids to school, if the school is far away, to go to hospital and so on. And so this tool was just put online to help people consciously make buying decisions, because one of the big problems if your population starts living outside of cities is that you need to invest much more money in the sewage systems, in the public transportation systems to get those people to the common services that you want to serve them with and for which they pay taxes. Whereas if they live in cities, it's very dense. It's from an economic perspective and thus for a government perspective, much more interesting to have your population centered in dense areas than scattered around your land, which is the famous Lintbebouwing in Flanders, where you just take an old national route, and it used to be fields filled with cow or corn, and now it's like the one house next to each other, but in a highly inefficient way. And so this was a huge backlash when they did that. Because like, who are you as a government to determine that I now have a low score in my house? I bought this, I wanted to live in the green outside of towns. Of course I know I'll need a car. Who are you to mingle? I pay taxes on my car. And so it was meant as a positive project to help people make conscious decisions about where to buy and to live. And it was a bit of a backlash, like, yeah, but now I want to see, and they didn't open it. I would have loved them to open it. They didn't open the model nor the data points on which it's based. And so people started comparing online and social media. Hey, my house is there and I have this score, and my sister-in-law lives there, and look at that, that's worse, and she has a higher score than me, how come? So that's unwanted outcomes when you get this. So it's very similar to this one. They're using open data. Where are the schools, where's the public transport, and they ended up with a huge public debate on property tax. Because maybe, somebody said, the chief architect of Venice, maybe we should incorporate this in the way we tax houses. if you decide to live in an, from society perspective, expensive off-city location, you should pay the taxes, extra taxes for that, because otherwise the others are... And so we get a whole societal discussion about what is a fair tax base, and should we end, and those discussions in Belgium are forever, which transfers to who, in which party of the country, is it the cities to the people living on the green outsides, is it the Flanders to the Walloons, and so on. So very interesting data there. Today, by the way, there was a new data set, it was in a newspaper, headlines, that there's transfers in between the provinces in Belgium, and so Limburg, they're getting more money than they're paying, and so they should be in the lists. Like I would say the cliche was always that Flanders is paying for Wallonia, but it turns out there's also interprovincial transfers. And so what I find interesting that those elements weren't in the public discussion before. And as long as you keep repeating that, people start accepting, like, yeah, Flanders is paying for Wallonia. Whereas if you see the numbers and see, like, wow, actually, richer cities and regions are paying for poorer part of town. That happens everywhere. And so, is it between towns, countryside? Is it between rich provinces, which happen to have a big harbor, which creates lots of economic wealth? And you give that to the ones who used to have coal mines and are still very busy in trying to transform their economy outside of tourism. And I'm just spreading some cliches here. Don't quote me literally on that one. So, engineer your features using external APIs. So you can really do a lot there, and it's really like something that I'm a big fan of having afterwards your results in APIs and boost the performance of your system and the usage by being allowed to do that. So this is the part where I open up to your questions, but I feel from the interactivity that there's a lot of more need for pizza, but go ahead, shoot. Was this interesting, first of all? Yes, that's good to know, thanks. So at least we didn't all... I'm going to start handing out this, because while I ask my extra questions, you can start filling in the satisfaction survey. Thank you very much. I think you've done a few before too, right? Yeah. You got them every time, so yeah, this is the one. So what's the metadata on this one that we could use to track this session? It's blue paper. So, just by the color, we could know that this session, of course, the title is already material. Those are the extra ones. Did you already cut the... not yet? Yeah, I think we're gonna... I'll take the questions offline and we'll have the pizza in the meantime. So everybody, come to our... I'm just gonna do this for the camera. Lucas, you have the dates of... I'm gonna win some time now because I want to make sure it's the right date that I'm gonna propagate now.
The days of the adventure course?
Yeah, no, the hackathon. Oh. I thought it was the 25th, but I want to make sure that...
Between November 29th
29th of November 2019 we'll have the hackathon, so everybody who wants to come there feel very welcome. Everybody following this course, you're automatically enrolled and free to come. It's part of the package. For those of you who want to follow the advanced course, you just go to the website of Beta Corework, you take the Big Data tab, and you can enroll for the advanced course. It will start in September. The exact date, Lucas, you have it in front of you? So as of September, when you enroll, you get the dates. Go ahead. So the prerequisite is that you do know that you have a laptop and that you have basic coding skills. Because otherwise, you'll just be watching what other people do. So if you've never written a line of code, then I would not encourage you to follow the advanced course because you'll be lost. But if you have a laptop and you've already installed a virtual machine with a development environment on it, then you're perfectly qualified to follow the course. And in each course, there's going to be a trainer, coach up front, and we'll take you through a step-for-step approach with certain more advanced participants can do more advanced, and the ones that are just starting with zero pre-knowledge, they get the step-by-step explanation of, like, here's a sample, do this, the hello world type of thing, like you type your code here, you go to a browser, looks what it looks like, it went through a web server, you just built your first web page, that sort of approach. But I would say that having had a coding class in high school or university would help you. having done coding on the job helps even more. And if you haven't done that, I'm afraid that you're going to be frustrated because you'll hear so many information and get so many instructions that you just can't keep up.
In terms of languages of coding?
It's language agnostic. So it's really about the, we will not entertain you with syntaxes in a certain platform how to do it. We will prepare a virtual machine where all the tools are pre-installed. We will try to have it available. So we'll have one machine locally to do big data, so neural networks and stuff that run on it. So a very local machine that we don't need to go to the cloud and compute over there, where we can do internal tests here that each of you can access. But the main goal is that you're able to install the virtual machine, which we'll send you up front. It has the full tech stack involved. So otherwise, we will lose the first hour of our meeting in now install this tool. It doesn't work on your machine and so on. So we want to skip that. You come to the class with the VM installed, or you install it on entry. We'll try to stick to one virtual machine platform. We pre-install the tools in there, and then we run you through the explanation about the tools that are in your VM now and how they can be used, and there will be a data set either on your machine or on the local network that you can then start using. So that's the whole idea of this course. Every 1 or 2 courses, we will work around one tech stack and we will learn you how to work with that. Sounds like fun? Yes. Yes, great. How many people would follow that? Just a show of hands. 1, 2, 3, 4, 5, 6. Wow, 7, 8, 9. Good.
When is
September.
the deadline for?
The deadline to enroll will be end of August. Just for us to size, I don't expect to have more than 80 people physically coming here. As you see, we've been upping our video gear during the sessions. This is the second iteration. We will have the new projector, which has higher luminosity, so that will also make it easier to project. And we'll always have the live feed, but for this course, it would definitely help you to be local, because if you want to use the local compute power or the local network to access certain of the data sets that we might pre-prepare for you, it would be good to be here, because I'm not sure it will always work remote.
And there's the possibility to follow remotely.
Yeah, you can follow remote, but like now, certain people are following. I hope they're still there. Have you cut the video feed in the meantime? Have you cut the video feed? No, you can cut it now. Bye-bye.